Hello everyone, so this is chapter 9, electric power and energy. I want you please to get ready on your notebook, so please open your notebook on a new page and write the title, the date as well. Today we are December 18, this could help. It's very important to start writing the outline. So as you can see, this chapter is very important for brevet and yet not very long. If you go back to chapter 8, resistors, it was a bit more tough and it was longer, okay? But yes, we still need to use the fact that Ohm's law, U equals Ri. We need to use the fact that resistors in series, you find are equivalent, resistance in parallel, you find are equivalent as well. And we still need to use the fact that in series, the current is the same, in parallel, the voltage is the same. So everything we learned in chapter 5 and 8 will still be used through chapter 9. So if you want, you can pause the video to write the outline. The first section is electric appliances. So if you go around your house, you will see different appliances. On each of those appliances, you see many inscriptions. If you look well in here, you would see 800 watts, 220 volts. For this fan, you see 30 watts, 230 volts. And this is a hair dryer. Look, the watts is huge, 1200 watts. And you have this volt or that volt because it switches depending on the voltage, you know. In all of Lebanon, the voltage is 220 volts approximately. When I was a kid, it was 110 volts. I still remember. If you go to the States, it's 110 volts. I think 110 volts is better for safety, but 220 volts is better. It's cheaper anyway, you know? So this appliance can be used for both voltages. I think it's an automatic switch inside. So these inscriptions, what do they mean? It's the rated power and the rated voltage for the appliance to function normally. So every time they tell you what the inscriptions are, what do they mean? You're right, it's the rated power and rated voltage for the appliance to function normally. Power is obviously in watts, and voltage is obviously in, what do you think? In volts, right? All right, so we start now with electric power. I'm gonna grab a pen and start writing, but before grabbing a pen, I want to remove this box because it's bothering me. Grab a pen to write the equation of a power and probably have this a bit thicker. Yeah, so power is equal to U times I. U again is the voltage and I is the current, okay? So if you want the triangle for this law can be like that. So please pause the video at any time to take notes. So P is U times I. Now I need help writing the units. Let me try it in green and have a thick pen. I is in amperes, it's the current. And U is in volts. Power is in watts, W-A-T-T for watt, and the abbreviation is W, capital W, okay? So what else? I need to give you quick reminders. If you have something in milliamperes, how do you convert to amperes? Yes, you divide by 1000. And if you have kilowatts, how do you convert to watts? Because you may have P given and you need to calculate current or U. To convert to watt, you multiply by 1000. So a kilo is 1000. Okay? And now, what if for the electric power, instead of having a regular appliance, I have a resistor? In this case, you can still use P is equal to U times I because U times I is applicable to any appliance. Please write next to it any appliance. But don't we know Ohm's law? What is Ohm's law? Maria, Yasmin, Peter, what's Ohm's law? Ohm's law is U equals Ri. So instead of U, I want to plug R times I. So the power now will be U times I, but instead of U, I'm gonna write R times I. And all this is multiplied by I again. So I will end up having power is R I squared times I squared. Okay? Probably we should take an example. So let me insert a new slide, this. I'm gonna call it example. So let me remove the pen. I need to remove the pen. I'm gonna say example. What if I have power to be equal to 200 watts and R is equal to 100 ohms, and the question is find the current. Okay, so I will use the equation P equals RI squared. Okay, this will be 200 to be equal to R, which is 100 times I squared. Okay, now let's calculate I squared. How do we do it? We do 200 over 100, right? The answer is 2. Now, how do you find the current I? How? Think about it. If you have I squared to be 2, what's I? It is radical 2. And if I'm not wrong, radical 2 is 1.4, right? It's 1.4. And the unit for current is amperes. So I wanted to give you this example just to make sure you know how to deal with I squared. Okay, I'm gonna stop the video now and probably later on continue throughout the outline. Thank you so much.